Hey there, in this video we're going to look at a few more examples simplifying problems using our properties of exponents. And it's going to be really helpful for us to break these problems down into just little steps using one or two properties at a time. So let's start with this fraction on the left, which has an exponent outside of the parentheses that needs to be distributed to the numerator and denominator. In the numerator, we have -3 squared and x squared, and in the denominator we have 4 squared. So we can evaluate those numbers. -3 squared is -3 times -3, which is +9, and 4 squared, 4 times 4 is 16. There's nothing else that we can simplify in that fraction, so now let's do some steps for this expression on the right. First thing I notice is we have x to the power of 0, and anything to the power of 0 is equal to 1. A 0 exponent is basically saying something canceled out, anything divided by itself is equal to 1. We still have 8 in the numerator of this fraction on the right because the x has the exponent 0, but 8 does not have an exponent on it, so this is still 8 times 1 in the numerator. And there's nothing we can do with this x to the power of 10 for now, so we'll just bring that down. So now we've simplified separately the fractions we had on the left and the right, and our last task is to multiply these rational expressions together. There's a couple of ways we could do this. We could multiply across and multiply the numerator times the numerator, and the denominator times the denominator. And if we do that, we'll get in the numerator 9 times 8 is 72, and we still have x squared in the numerator. And in the denominator, 16 times x to the power of 10 is just 16x to the power of 10. Then from here, we need to simplify this fraction to get our final answer. So let's look at the coefficients and then the variables in this fraction. For our coefficients, the fraction 72 over 16 can be reduced if we divide by a common factor. The greatest common factor of 72 and 16 is 8. So we can divide the numerator and denominator by 8, and we get 9 over 2. Then looking at our variables, using the quotient property of exponents, when we're dividing, we will subtract those exponents. 10 minus 2 is 8, and x to the power of 8 is in the denominator of that fraction because the bigger exponent was in the denominator. So that's one way we could finish this problem, but you might have simplified it a different way. And we can start dividing common factors from the top and the bottom of either fraction with each other. So if we look at this 16 that's in the denominator on the left, and we have an 8 in the numerator on the right, well, the fraction 8 over 16 by itself would just simplify to 1 over 2 if we divide the top and the bottom by that common factor 8. So we can do that right now and simplify this 8 into a 1 and this 16 into 2. Another thing that we can notice is there's a common variable x in the numerator and denominator, and if we just had the fraction x squared over x to the 10 on its own, that would be 1 over x to the power of 8, because when we're dividing, we subtract those exponents from each other, and the bigger exponent is on the bottom, so this x is in the denominator. So we can do that right now as well. Divide the top and the bottom of this fraction by x squared, and that just leaves us with x to the power of 8 in the denominator. That's going to make it easier for us to multiply, because now we're multiplying just 9 over 2 times 1 over x to the power of 8. In the numerator, 9 times 1 is 9, and in the denominator, 2 times x to the 8 gives us 2x to the power of 8. In this example, we're going to look at a negative exponent as well as some of our other properties. I would recommend in any expressions that have negative exponents, you deal with that first. That way, for the rest of your problem, you're only having to simplify things using positive exponents. And what a negative exponent means is we need to take the reciprocal of something, or in other words, flip which side of a fraction something is on. To turn this negative 5 into a positive exponent, we need to move that term into the denominator of our fraction, and that exponent will become positive 5. Notice that I'm not moving this 3 into the denominator because this 3 does not have any negative exponents on it, so it should stay where it is. So when we take care of that, we still have 3 in the numerator, and in the denominator we have x squared times x. I'm sorry, that's x to the third times x squared times now this x to the power of positive 5 that we moved because of the negative exponent. After that step, there are a couple different directions we could go in. We could distribute the exponent 4 that's outside of the parentheses to the top and the bottom, or we could first simplify what's inside of the parentheses and then deal with that exponent. Let's simplify the inside of the parentheses first. In the denominator, we're multiplying all of these common bases together, which means we should add the exponents, and 3 plus 2 plus 5 gives us 10. We still have the coefficient 3 in the numerator, and now we can distribute this 4 to the numerator and denominator of our fraction. So this becomes 3 to the power of 4 over x to the power of 10 to the power of 4. And to simplify this, when we raise an exponent to another exponent, we'll multiply those exponents together. So that gives us x to the power of 40 in the denominator. And in the numerator, 3 to the power of 4. Remember, not 3 times 4, but 3 times itself, 4 times, and that is 81. All right, let's do one more with some negative exponents, 0 exponents, and all of our other properties to review as well. Like we did in the previous problem, I would recommend you start with this negative exponent. So let's turn that into a positive exponent by moving it into the denominator of our fraction. If we just do that step, we'll be left with 4x to the power of 0 in the numerator. We still have all of these other terms in our denominator. And now this y to the power of positive 3. Next thing that's easy for us to simplify is this x to the power of 0. Anything to the power of 0 is equal to 1. So instead of 4 times x to the power of 0, we can think of this as 4 times 1, which just gives us 4 in the numerator. Before we can multiply everything in the denominator, let's take care of just this part that's in the parentheses. If we distribute this exponent to the 2 and y to the power of 3, 2 to the power of 2 is 4, and y to the power of 3 to the power of 2 becomes y to the power of 6 using our power property where we multiply those exponents together. So after that step where we took care of the terms in the parentheses, now let's simplify the denominator of this fraction by multiplying all of these together. We're going to multiply the coefficients, 5 and 4, which gives us 20. And we're going to add the exponents together on the common bases. Y by itself is y to the power of 1. So we have 1 plus 6 plus 3 gives us y to the power of 10 in the denominator. Since our final answer is a fraction, we should check if it's possible to simplify anything else. And we can, in this case, simplify if we divide the top and the bottom by a common factor of 4. So that will reduce to just 1 over 5 times y to the power of 10.